I first came to the laboratory as a postdoc in physics.
I started here as a postdoc quite a long time ago.
The goal of working at this laboratory started when I was in graduate school.
So I feel I've been very lucky because I've worked with the best people on the best facilities.
I came to the lab with a PhD in physics and a master's of computer science. So there are two things that excite me about my job here. The one is high-performance computing, which is the passion I kind of came to the lab with as part of the ASCII program, developing software for massively parallel computers. That continues to be an excitement, especially as the computer architectures have evolved. I get excited about how we can make our software work on those computers and what new problems can we tackle with those computers. The second thing that excites me, and this is something that took a few years with me after I got here, was appreciating the mission-oriented work. My philosophy has always been that we're paid to do the best science that we can do, so we have to be technically excellent. And so, that's, I think, what makes the lab so good, is that we are technically excellent and we always do a good job. So you always have to keep that in mind. You have to find something you love doing, and you're not going to love everything, but you know, some things you have to do for the good of the lab, but you always have to do it in a technically excellent way.
So I've had the privilege of working in Washington, D.C. on 3 separate occasions as a detailee at Department of Energy headquarters, and then from there I moved to the Office of the Director of National Intelligence at what was called the JAIC, the Joint Atomic Energy Intelligence Committee. I was there in a support role for several years. But that set me up for another opportunity. In 2012, I was named the chairman of this committee. It's an interagency technical intelligence analysis committee. And I was asked to really come in and revitalize the organization that had sort of fallen off people's radar, and the impact was not as strong as had been previously.
Originally, I just thought that writing computer programs was for me to do on spring break for fun. And it wasn't until I came to the laboratory that I realized that they were going to pay me to do this thing that I really enjoy doing anyway. So, you know, that's kind of how I got started. The thing I most enjoy about it is you get almost immediate feedback when you screw up. You know, if the problem crashes or energy isn't conserved, you kind of learn that in a day. Whereas in other fields, you know, you might have to wait weeks, months, years before you know how you're doing.
I've worked a lot in energetic materials and high pressure chemistry. And one thing I like about energetic materials, it's a very interdisciplinary area. So it's chemistry, but it's chemistry occurring at a time scale that most chemists don't think about, and at very high temperatures and densities that most chemists don't think about. And it also has a lot of material science that goes into it, because we're talking mostly about solid materials, and the solid materials have crystal structures and they have defects. There's a lot of, and then we also have polymers involved, so there's a lot of material science.
We have a program where external researchers make proposals, submit proposals for science experiments. I'm involved with that by collaborating, developing their experiment from the concept to something that's executable, and participating and overseeing what they do in the facility to be able to get quality data that answers the questions that they're interested in. Some of these questions include issues related to astrophysical phenomena in outer space, gas cloud interactions, planetary formation, star formation, etc. It's remarkable how many of the world's top thinkers and researchers are involved with NIF. I have the opportunity to work with outstanding people, outstanding both internal to the lab and external. I find that collaborating with people with other scientists, with a large group of scientists, is exciting. It's interesting. There's nothing that a large group of scientists like at Lawrence Livermore can't do.
Everybody here at Livermore knows the answer to that, because that's all we do, is work on teams of people to solve problems. And it's because we have such large problems, complicated problems, you know, providing energy for future generations and assuring the safety and security and everything of the nuclear stockpile. Those are complicated problems and people can't do them on their own.
You always have to have some sort of self-awareness in what your sponsor wants. So you have to not like go off on a tangent, but you have to deliver what your sponsor wants at the same time being honest about it. So if you really don't know something or something's impossible, you have to be able to say that.
Any given day, I can be focused on a basic physics question, working through the consequences of some hardware change, helping users answer some stockpile stewardship question. There's so much variety there, and the opportunities to make a contribution and learn something new means you're never going to get bored.